Alright, Algebra 2, Section 5.1 is titled Modeling Data with Quadratic Functions. Well, before we get to the data part, you need to know what a quadratic function is. It's different from a linear function. There's the standard form of a quadratic function. Now, remember this notation, f of x, is a fancy way to say y. Okay, but f of x equals ax squared. Simply put, that is the most basic type of quadratic right there. But a quadratic function could have more than that. For instance, and this is called the quadratic term right here. It's called a quadratic term because it is squared. But this could also have, oh look, something to the first power. That is your linear term. So it could have more than just a squared term. It could have a linear term. And it could have one thing more than that. It could have a constant term. So a quadratic function in standard form has the squared term first. If it has a linear term, then it has the linear term second. If it has a constant term, then the constant term is last. So when they ask you to put things in standard form, you'll make sure that you do that. For instance, example 1 talks about determine whether each function is linear or quadratic. So they start off with something that is not simplified. And you must go through the process of simplifying this. Then you can decide whether it's linear or quadratic. Okay? So, as many of you have seen, I use the box method for foiling, but you can choose to use whatever you want. If you're big into drawing the arrows here and drawing the arrow here and here and here, sometimes kids get real confused with that. Other kids like it a lot. So you use what you want, but I'm going to, negative 8x, as long as I don't make a mistake, we'll be good. X times 3 is 3x, and then negative 12. Now I could start adding like terms. Obviously, the 2x squared does not have a like term, but I see right here these have a like term, and then the negative 12. So this is simplified form. My decision, is it quadratic or linear? I'm going to choose quadratic. Why? Because I see the squared term. So this is a quadratic function. Now, what's the quadratic term, the linear term, and the constant term? Well, the quadratic term, 2x squared. The linear term, negative 5x. The constant term, negative 12. Those are the three parts, the quadratic term, the linear term, the constant term. So you will be asked to identify those. In example B, they give me a different one. Which illustrates a point that I would like to bring up here as soon as I get to that particular part. So obviously I'm going to distribute this and get 3x squared minus 6x, and then distribute this and get minus 3x squared and plus 6x. Alright, you're going to notice that those two terms cancel out. One's positive and one's negative, and they add up to 0. So we end up with f of x equals negative 6x plus 6. Now, at the beginning of this problem, I might have suspected it was quadratic because I saw a squared term. But guess what? After I did all the simplifying, I lost my squared term. There is no more squared term. So this is a linear function, right? Y equals mx plus b. That looks like a linear function to me. It's a linear function. And so when they ask me for the three parts, the linear term, the quadratic term, the constant term, the linear term, there is none. The quadratic term. The quadratic term is missing. So there is no quadratic term. negative 6x, and positive 6. There's your linear term and your constant term. Okay, so you'll be practicing some of those in section 5.1. Now, how do I graph these things? Well, the shape that we're going to be getting looks something like this. It's called a parabola. And it's either going to have a minimum point or it's going to have a maximum point. And that's all based on whether it opens up or opens down. Now, in either case, that minimum point or maximum point is the place where it changes direction, and we call that point the vertex. Okay? So the vertex is either the minimum point or the maximum point. It's where it changes direction. So very important point. We will ask you about finding the vertex. Every parabola also has a line which cuts right through the middle, a vertical line in the cases of the ones that we're dealing with. We won't worry about any of the horizontal ones for a while. Second semester we'll talk about those. But these particular ones right here that open up and down have a vertical axis of symmetry. And because we're dealing with vertical ones, all of ours are going to look like this. X equals some number. So x equals 5, x equals negative 7, x equals, this one looks like it's been split right down the y-axis. Therefore, it would have an axis of symmetry of x equals 0. Okay? This one would be x equals some negative number since it's been shifted over to the left side of the y-axis. Okay, but in any case, there's still going to be some line which cuts it in half, where you see a mirrored image on one side than the other. So you might be given a particular function, and actually they give you the picture. Okay, so for instance, I'll just show you this one here in the textbook. It says below is the graph of, and they give me the actual picture. Identify the vertex, okay, the axis of symmetry, and identify points corresponding to P and Q. Now, that doesn't mean that they want you to identify P and Q. Here's what it does mean. So the vertex, obviously 2, 0, right? 2 to the right, 0 up. Right there it is. The axis of symmetry, x equals 2. X equals 2. Take notice of something right here, that the vertex shares the value that's in the equation for the axis of symmetry. That's important because the axis of symmetry goes through the vertex. Okay? Now, point or P has the value 1, 2. That's clear from the picture. What they wanted when they said identify points corresponding to P and Q, they mean find the other point on the other side of the axis of symmetry which goes with letter P. And obviously you can see that they have called it P prime. They put out a little single hash mark. And we remember from geometry that was read P prime. And so you can clearly see that it has been moved just over to the other side of the axis of symmetry, and it has the point 3, 2. While Q is over here, and it has to go, if it's 2 units to the axis of symmetry, you carry it over 2 more to find Q prime. Okay, and that's at the point 4, 8. Right? If 0, 8 is the point Q, 4, 8 would be Q prime. And I'll ask questions like that on tests and quizzes, so make sure that you understand. I'm not asking for P and Q, I'm asking for the values on the other side of those. So we can ask questions about those kind of things. For instance, here's a couple pictures you can take a look at. So vertex, that's 1, -1. right here, 1, negative 1. We can see that if Q is 2, 0, then, and it's only 1 unit away from the axis of symmetry. Oh, by the way, the axis of symmetry is x equals 1. X equals 1. And if I move across that line, that would be 0, 0 for Q prime. P is located over here. It's 2 units away from the axis of symmetry, so 2 more units to the right would put it over here, and that would be the value 3, 3. And then you could do a similar type thing here, looking at negative 1, positive 2 for the vertex. X equals negative 1 would be your x equals negative 1 would be, and folks, for those of you who think you could just list negative 1 as the as the axis of symmetry, you're sorely mistaken. You will lose points if you decide that you're just going to write, see for instance right here, if you just write the number negative 1, you're in trouble. You need to write x equals negative 1. Okay? Just like they did back here. X equals positive 1 for this axis of symmetry. P prime, well, that's going to be right here. And since P was located 1 unit away from the axis of symmetry, I go 1 unit this way. And I get 0, positive 1 for P prime. Q prime is 2 units away from the axis of symmetry, so I carry it over 2 more units. So I ended up with negative 3, negative 2. Okay, to find that value. So, simple stuff on graphing. Now, the last thing, the most difficult thing probably, which I know I'm going to run out of time, and I'm going to have to create, this is part 1 of the video. I'll have to create part 2 at lunch because the next example will take a little bit more time.